Hello, so today we are going to do this problem called maximum rows covered by columns, which is part of this week's bi-weekly contest. So the problem says we get a zero indexed binary matrix, and we get an integer columns or cars that denotes the number of columns we have to choose. So we need to choose a set of columns depending on some rules, and the number of these columns is this parameter. And a row is covered by a set of columns. We can say that a row is covered by X amount of columns if each cell in the row has a value 1, and in that value place of value 1 lies one of the columns that we select in this set of columns. It will be clear once we look at an example, and the goal here is to return the maximum number of rows that can be covered by a set of columns. So the maximum number of rows that we can cover with this number of columns, right? So if you take a look at this example here, this matrix, right? So we have columns equal to 2. So we need to choose 2 columns such that they cover the maximum number of rows. And cover means just the ones, the position of 1 aligns with the position of 1 in a row aligns with the position of the column, right? So the maximum solution here is to choose this column in the far right and in the first one, right? That way basically we'll cover the one in the second row and the one in the last row, right? The two ones in the first. So so here we can count that the row at position 0 is covered, the row at position 1 is covered, the row at position 3, last one, is covered, but the row at position 2 is not covered. So why is that? Because the row at position 0, it's all zeros anyway, so it's covered by default because there is no 1. The only condition is all the ones lie in the chosen set, so if there is no 1, we can consider it covered. The second one, well, we chose a column for the position of 1, so the first column, and we chose 1 for the position of the last one, right? So we covered all ones in that row, so it's covered. The second one is not covered because the second one here in position 1, position 1, 0, 1, 2, 1, is not covered by any of the columns. We didn't choose column 2, so it's not covered, so this row is not covered. The last one is covered because we did choose the last column, so this one is covered. Which means we were able to cover 3, and if you try, you can't go past 3. Yeah. You can choose, let's say, maybe the second column, that way you cover the third row, but if you do that, you won't cover the first row here, row at index 1. And so the max we can do anyway is 3. So that's the solution here. If we look at this matrix here, columns is equal to 1, so we can just choose the first one. That way we cover the first row here at position 0 with this one, and then this one is 0 anyway, so it's covered, so we return 2, right? So what we return here is the number of covered rows. So that's pretty much the problem. Now let's see how we can solve it. So for hints to solve the problem here, let's look at the constraint. So you can see the number of columns and the number of rows is at most 12, right? Which tells us that we can really do like a search that is 2 to the power of 12, or we can really do expensive search here because the number of rows and columns is small, right? So the first idea would be, well, we have only a columns number of, let's call this x number of columns to choose. So let's try all the x combinations and see which one will cover the most rows, right? So that's the most straightforward solution, which is let's try all combinations of rows. Of columns, sorry. Let's try selecting all combinations of columns. Of course, length columns. We are limited by this. We can't the number of this, right? I'm going to call it x because at most x columns, right? Just so that it's easier for us to read. Okay. Okay, so that means basically in Python, you could do it manually, but in Python we can use arrow tools, right? So let's say selected columns, let's call them. In combinations. So in Python, this function here in iter tools, let me just show you iter tools. Combinations. Basically, we pass to it the range of the elements to choose from, and we pass r, which is the length of how many the length of a single combination, right? So what we want here is all the columns, and we want the length to be x, right? The number of columns we want to select. And so what should we pass here? This is just the range of the number of columns overall in the matrix. So let's make this m, and let's choose the let's call columns C and R. So R would be the number of rows, C would be the number of columns. So that would be the length of the matrix and the length of the first row. So here we want to try all the columns from 0 to C, right? Which means basically, so let's say we have a matrix that has maybe 5 columns, right? Right? Or maybe let's pick 3 columns, right? And so that would mean we want to choose between 0, 1, 2, right? And so let's say x is equal to 2 here. So what would happen in that case? Well, in that case, this combination here will tell us, okay, let's try 0, 1, let's try 1, 2, and let's try 0, 2. So we try all the combinations and see which one works, right? Which one gives us the max number of covered rows, right? So since we want the max number of covered rows, let's have a variable here to keep track of that. And so what we want to find is how many rows can we cover using these selected columns. So let's write a function to do that. So number of covered rows using selected columns, right? So we want to use these selected columns and see how many we cover, how many rows we cover. And so once we get that, we want to use the max to check if it's the max one, if it's better than what we have so far. If it's better, let's assign it. However, there is one thing. If the number of covered rows is equal to the number of rows overall, that means we can't do better, right? That's the best we can do, is cover all the rows. And so if that's the case, then just return. There is no need to do another pass because you can't exceed R here. So we just return the number of rows. Or you could say also return covered rows. They are equal, so it's the same. Okay, so now how do we write this function number of covered rows? So we get the selected columns, right? And now we need to see how we, so we want to return the covered rows. So let's return them, and let's see how we compute it. So we want to look at each row and see if it's covered by all, if using all these columns, that will cover that row, right? And so we want to go through each row. So just enumerate, and want to check if this row, if selected columns, right, cover all ones in this row. So that's what, if it does, then we increase covered rows by 1, right? So that's what we need to check. So we want to, how do we get the covered ones in the row, right? So let's call these the covered places. So this would basically, for a row, let's say maybe a row that is 1, 0, 0, 1. And let's say the columns we have, maybe it's 0, 3, for example, maybe. So this is the row that we have. 2, 3, 4, right? So what we want to know is where is the covered row? With these columns, do we cover all the ones, right? So the first thing to do is to see what are the covered places by these columns. So that's the first thing. So to do that, well, we of course need to do it for each column of these columns. And so we need to just say row at position J. So that would give us what is covered by these columns. And so in this specific case, what is covered is position 0, that's a 1. position 3, that's a 0. So those are the values that are covered by these columns. Now, how would this help us? So we know it helps us in that if the number of ones in this is the same as the number of ones in the row, that means we were able to cover all the ones, right? So if number of ones in covered places by the columns is equal to the number of ones in row, that means we covered all the ones, right? By definition. Notice here, because these 0 and 3 don't cover all the ones, there is this one and this one here, this condition fails, because here we will get the number of ones is just 1, but the number of ones in the row is actually 3, so they are not equal, so they don't cover it, right? And so how do we check that? So we want to check how many ones are in the covered places. So let's say ones, that's what I did with this here. So 1 is in covered places. So we count 1. I'm explicitly doing a lot of variables here so that it's easier to understand. But yeah, you could just put this here if you want, right? But this is for understanding purposes. So with this, we want to get the number of ones in covered places, right? So in this case, that would be just 1. So we count, this function in Python will count how many ones are in this array. So this array, that will return us 1. So we want to check how many ones in the row. So let's just do some pre-processing here to get all the ones in each row, right? So let's call it number of ones in row, right? Let's have maybe just a row that count 1, so that will give us the number of ones in a row, and row would be just in matrix, right? So basically this way, with I, we can just say number of ones in row at position I, and that will give us the number of ones for that particular row. And so that way here we can check equal to the number of ones in row at position I, because that's the row we are looking at. And if this is true, that means we can cover all the ones. So if all the ones covered by the columns are equal to the number of ones in that row, that means we covered all of them, so we can increase our covered row count here. And just return it. And that should be it pretty much. Yeah, we filled this function. We did our logic here. The only thing left to do is to return the max covered, and we should be good, right? So try all the columns. Try selecting all combination of columns of length x, and see how many covered rows result from that, and then take the max. So pretty simple, actually. So let's run this. We need, yeah, just Python syntax. Okay, let's use more test cases. And let's submit. Cool, so that passes test cases. Yeah, so I think that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.